One thing that's important to know about wave calculations is that the velocity is always constant if you're in the same material or the same density. So if the rope that I'm using has the same thickness, or the spring has the same stiffness, or the water has the same depth and temperature, or I'm in the same medium, like I'm air, or I'm just in water, or in wood or whatever, the velocity of whatever wave I have will always be constant. And the way that we measure velocity is we basically travel. We either look at one area of compression and see how it passes through, kind of like looking at just a pulse, or just a crest or just a trough and see how far does it get in 1 second. So it's meters per second. The wavelength we've already talked about, whether we're talking about a longitudinal or a transverse wave, it's one full crest, one full trough, or one full area of compression, one full area of rarefaction. The frequency is number of wavelengths or cycles every second. So this is kind of like the way we think about charges or current. I'm standing in one space and I'm counting the number of wavelengths that pass by me in a number of seconds. So you can either write this as wavelengths or cycles per second, or we also use the unit hertz. So if I'm looking at this 1 second time and I'm getting 1, 2, 3.5 wavelengths in 1 second time, that's my frequency. My frequency is 3.5 per second. If I want to increase the frequency, right, increase the number of wavelengths that I can pass in the same 1 second burst of time, the wavelengths have to get smaller. Right? So my relationship between my wavelength and my frequency, because my velocity is going to stay the same, is that they're inverse relationships. If I want to increase this, this has to go down. Use these calculations. I have example A. A wave has a frequency of 45 hertz and a wavelength of 10 centimeters. What's the velocity of the wave? So remember, velocity has to be in meters per second. So I have to convert 10 centimeters to 0.1 meters. And then I just multiply the two and I get 0.45 meters per second. Here's another example of a question that can be used. So sound travels in water at a speed of 1,450 meters per second. A sonar with a frequency of 115 kilohertz is sent by a submarine, and a ping, or the echo, is heard 0.02 seconds later. How far away is the object? It's got to be really close if it's 0.02 seconds. And what's the wavelength of the sonar? The really important thing about this is that whenever you have something that's bouncing off, whether it's reflected light, or whether it's an echo, or I'm dropping something and I'm hearing the sound come up, actually, that's not an echo. I'm shouting across a cannon and I'm hearing it come back. Echo means that you're bouncing back. So it's twice the time that it takes for one journey. It's the forward and backwards when I hear the ping. So 0.02 seconds is the total time. If I wanted the time just from the object to the sonar, it would be 0.01 seconds. So whenever you see the word echo or something that implies echo, always divide the time by half. So my velocity is 1,450 meters. I want to know the distance. That's just our regular kinematics. Velocity is equal to distance divided by time. Rearrange, distance is equal to velocity times time. I plug these away. It's only 15 meters away, which is kind of scary if you're talking about a sonar, because sonar's like, on a sub, it's huge. 15 meters away is just basically right in front of your nose. What's the frequency? So the frequency is 115 kilohertz, which we have to remember is 1,115,000 hertz. So I'm looking for the wavelength. I use my velocity is equal to wavelength times frequency. I rearrange for wavelength. And so 1450 divided by 115,000 is going to be equal to 0.012 meters. So it's a 12 centimeter wavelength of sonar. So this is where I can use my velocity either in my regular kinematics equations if I'm looking for distance. So whenever something's asking for distance, use this velocity equation. Whenever we're talking about wavelength or frequency, we use this velocity. So the velocity of the submarine, it's not saying the velocity of the submarine is 14,500. That's like impossible. It's saying that the sound that's coming from the sonar is 1,450 meters per second, but we're still using it to figure out how much ground that sound wave traveled in that amount of time.